Let's take a look at hydrogen fuel cells and the impact green hydrogen could have on greenhouse gas emissions and the Earth's climate. First, let's go over the basics of hydrogen and what it's like as a fuel. Hydrogen is the most abundant element in the universe, mainly due to its presence in stars. On Earth, it only exists naturally when combined with other elements, such as the formation of water. Because it is not found freely on Earth, hydrogen is referred to as an energy carrier and can be used to store or deliver energy. Hydrogen can be used as a fuel when consumed in a fuel cell. In principle, its use as a fuel shows promise as a solution for the current problem with carbon in our atmosphere, as it produces only water when consumed. Fuel cells use a chemical process to turn hydrogen into electricity. As long as fuel is provided, electricity can be generated. The hydrogen fuel is passed to the anode of the cell, where the electrons and protons of hydrogen are split. An electrolytic membrane splits the anode and the cathode, where the electrons cannot pass, and are therefore forced through a circuit which generates the electricity. The split components are then combined with oxygen at the cathode to produce water. This production of water is one of the main advantages, as heat is the only other emission produced when electricity is generated. Another advantage of hydrogen fuel cells is that if properly stored, hydrogen will not dissipate through the containing device, unlike conventional batteries. Hydrogen is also converted directly to electrical energy, bypassing the step common in internal combustion engines, which first converts the chemical potential to heat. Additionally, there are less moving parts, which allows for a greater reliability and serviceability compared to conventional engines and motors, and without these moving parts, hydrogen fuel cells emit minimal noise. And while hydrogen is often discussed as an alternative for mobile equipment like vehicles, these advantages also make it a promising option for stationary power. According to the 2019 Fuel Cell Review by E4 Tech, approximately 2,300 megawatts of hydrogen fuel cell capacity has been sold in the past 5 years. 31% of this purchased capacity has gone into stationary power applications. Stationary fuel cells are efficient, quiet, and can provide primary power or even backup power in the case of emergencies. Another advantage of these stationary fuel cells is that they take up less space compared to other clean production technologies. For example, a 10 megawatt fuel cell installation can be installed on 1 acre of land, compared to the 10 acres needed for equivalent output solar power, or the 50 acres needed for equivalent output wind power. However, there are disadvantages to hydrogen energy. While storage is effective when done properly, doing so is difficult, as liquid hydrogen requires cooling to negative 253 degrees Celsius, and as a gas, pressures of up to 10,000 psi are required. Hydrogen is also flammable in concentrations of 4 to 95% in oxygen, compared to gasoline that is flammable in air at concentrations ranging between 1.5 and 7%. Lastly and most importantly, as of 2018, 95% of hydrogen is produced by carbon-intensive methods, all of which add to the annual greenhouse gas emissions created by fossil fuels. Speaking of these greenhouse gas emissions, processes such as steam reformation involve a series of reactions between steam and the natural gas. 830 million tons of CO2 are produced per year due to these reformation processes, a total surpassing the yearly CO2 emissions of countries such as Canada and Germany. This annual contribution of 830 million tons is equivalent to the yearly greenhouse gas emissions of approximately 179 million passenger vehicles. In Canada, there are 34 million registered vehicles, which create about 162 million tons of CO2 yearly. It would take about 5 times the number of vehicles in Canada to match the annual CO2 output of the current hydrogen production. One way to reduce the emissions from hydrogen production is to eliminate the fossil fuels used in the production process, and instead use renewables such as wind and solar to generate the hydrogen. This procedure of using renewables is called green hydrogen. This method uses renewable electricity to split water into hydrogen and oxygen molecules through electrolysis. Currently, only 1% of hydrogen production is green. However, this technology is expected to see an extreme development in the next few years, with expected growth of over 1,000% in electrolyzers available for production by 2025. The Hydrogen Council has outlined an aggressive transition to clean hydrogen, stating that nearly 80 exajoules of global energy could be met with hydrogen energy. This would meet 18% of the world's energy demand and reduce CO2 by 6 gigatons. This pathway meets 20% of the CO2 reduction needed to meet the 2-degree warming target by 2050. As of right now, green hydrogen is only a small fraction of the world's energy production, but with growing demand and a need to reduce global emissions, green hydrogen and fuel cells may be an effective low-carbon solution.